All right, pretty simple stuff here. We're looking at direct variation. We know that the standard form, we're going to have y equals kx. We want to make sure we put our equation in that format to see if we can identify if it is a direct variation. If it is direct variation, we're also interested to know what our k value is. What's the constant of change, right? What are we doing to x each time to get y? So looking at this first example, it seems pretty clear on this one. My y's line up, my equal sign, my x's, and the only thing here is my k, and it looks like if I replace that here, it fits perfectly. So this one I'm going to say is a direct variation. I'm going to say yes on this one, and my k value is 2/5, right? Pretty simple there. Number 2 here is x minus y equals 0. A lot of people immediately say, no, that's not direct variation because it doesn't look like this one up here, right? So now this is one where you almost have to dig for a second, right? Make sure you rearrange things and put it in the format that's expected, right? Here I know what direct variation is because I've solved for y, right? So to quickly say no here before I solve for y is the error, right? If I just do one step, really, I can see what happens. I'm going to add y to both sides. It's going to cancel on this side, and what I end up with here is x equals y. Once again, not quite as friendly looking as I would want it to, but if I spin that around, I end up with y equals x. And again, it seems a little confusing, but if I have 1x, that means I have a 1 in front of it. Meaning my constant or my coefficient, we don't see it, but it's there. It's a 1, right? And now, this x minus y equals 0 looks just like my direct variation, right? Y equals 1x, y equals kx, and I can see that this is direct variation with a k value of 1. It's pretty easy. We just need to make sure we get it in this format and then double check.